Okay? Okay, then we can formally start. Very welcome, and very welcome everybody on the internet and the web broadcasting. So I will start by handing over to my colleague Joachim.
That they hear us on the web. Your Excellency, Mr. Ambassador, ladies and gentlemen, welcome to Vinnova, Sweden's innovation agency. It's a great delight to see so many people in the room, and I know that many will follow this meeting through the web stream as well. So there is a huge interest in the area. And I would also like to say especially a warm welcome to our guest from the UK. We're very happy that you have taken the time out of your busy schedule to come here. And I think it's a sign of the importance of this meeting that we will have today and the collaborations that will hopefully come of it from the start. If I should describe Vinnova with one word, it would be collaboration. We use our 3 million euro that has been allocated through the Swedish taxpayers to us every year to really incentivize collaboration. And therefore it's with great pleasure that I can introduce this information meeting on the Sweden-UK call for Eureka network projects, because it's really about collaboration multiplied at least 3 times. It's about collaboration cross sectors. It's about collaboration cross different technical fields, because you all know work in this area that getting the things to fly in air. It's not about a single technology or a single academic field. It's really about cross collaboration. And last but not least, it's of course collaboration across nations. And internationalization is really a key priority from the Swedish government, and it's a key priority for Vinnova. We're a small country located in the outskirts of Europe, but we're home to many global companies. So in order to stay attractive as a place to do R&D and innovation going forward, we need collaboration with partners around the world. So therefore I'm very happy that Innovate UK, the Strategic Innovation Program Innovair, has taken and the Aerospace Technology Institute has taken this initiative to launch this call and create projects going forward. So once again, warmly welcome to Vinnova. I really look forward to the discussion. Thank you.
Now, that was the wrong thing. Okay, thank you again. I'll start. No, it's working now, but we need this for the next presentation. And now we'll hear something from the Swedish Ministry and also from Excellence Ambassador from the UK here about the views of Sweden and UK on this collaboration before we go into actually talk a little bit more about what are we supposed to do in this call. So please, Carl.
Your Excellency, Mr. Ambassador, dear friends, I'm really delighted to be here together with you at this meeting about a joint call when it comes to aeronautics between Sweden and UK. And I see an inspiring gathering from academia, industry, politics, and institutes. I'm well prepared for this meeting, I think, not only for my colleagues at the ministry, but life has taught me something about the British aviation industry. And it's quite interesting because I talked to my brother this morning and I asked him, didn't we actually go to Farnborough like 1965 or something? Yeah, that's correct. That's correct. And we have a picture in the family album where we actually do like this when I think it was an Avro Vulcan starting, and I think the plane itself consumed like half of the jet fuel consumption in the UK today. So I'm well prepared, and of course, as a representative from the Ministry of Enterprise and Innovation, it is easy for me to promote initiatives that strengthen research, innovation, industry, and growth, and it all comes hopefully in a sustainable package, and that's really important. The joint funding call in aeronautics boosts our bilateral cooperation and will make us even more competitive and innovative in aeronautics. And I think it's fair to say that Sweden and the UK, we have had a very strong relationship for a long, long time. Over the centuries, trade and business have held central place in our cooperation. And actually in 1654, we entered into a friendship and trade agreement. And I think it just worked out well since 1654. And we are like-minded in very many different policy areas. A few examples are climate change, protecting free trade, global poverty issues. The list is very long. And Britain is one of Sweden's leading trading partners. Sweden exports manufacturing products like cars, buses, trucks, pharmaceuticals, wood, paper, metals to the UK, even e-health, energy and environmental technology, food, fashion, and the list is very, very long. And of course, there is also an already well-established cooperation in aeronautics in several fields. There are more than 1,000 companies, Swedish companies in the UK, which generate more than 100,000 jobs. And on the Swedish side, there are 1,000 British-owned companies in Sweden. And there are 30,000 Britons at least living in Sweden. And the number of Swedes in the UK is significant, approximately 100,000. And the conclusion is simple: we like each other and we like to work with each other. And our similar cultural mindset is a very good foundation for good cooperation. We know that already. And of course, it's very good to know that we are already good front runners when it comes to innovation. As we all know, Sweden is a very small country, but very successful when it comes to research and innovation. And regardless what institutes, the measurements you're looking at, we normally end up number 1, 2, or 3 in Europe and globally. Swedish R&D expenditure is also among the highest in the world. So together with the UK, we are also front runners and strong actors in the aeronautical industry. The representatives from the UK part of the industry here today are certainly proof for that. Last year, the Swedish government launched a Swedish aviation strategy. It's addressing all the important issues when it comes to aviation in society going forward, including sustainability issues. And of course, this is something that is important for the Swedish government and also for the UK government. We have also the government has decided on additional financing when it comes to broaden international cooperation. The government's decision enhances cooperation with partner countries like the UK, and the joint funding call is a positive outcome of this initiative. Swedish aerospace companies account for a turnover of over 20 billion kronas. The industry in itself believes that we will double that figure in 20 or 30 years. A lot of people in the industry are employed on the technological side directly, 15,000 people. But of course, a lot of the development is funneled down into other industries. So it's a very important part of the structure of the Swedish business society. As I said, during the next 20 years, we expect to see a growth of around 5% per year in aviation industry. That means that air travel will double in the next 15 years. And of course, Sweden's participation is about, can we contribute to world-leading solutions, including sustainability issues. And of course, a prerequisite to be successful is to have strong collaboration with other countries, with other companies. And I think this is a very, very important step in that direction. I think also that what we have seen in the last couple of years is that we have very, very strong competitors coming from Asia, especially from a very large country that have very high ambitions on the aeronautics side, and it's very important that other countries can meet up to that challenge. Hopefully, this will be one of many starting points for a long-term cooperation between the Swedish and British aeronautical industry, academia and institution that will stimulate innovation and growth. Thank you for your attention. Thank you.
Thank you very much, Carl. And thanks for sharing your experience of Farnborough Air Show. I could tell you I was there this summer for the first time in my life, and it was still a bit noisy, but I expect not quite as noisy as when you were there 50 years ago or so. And it was very nice, actually. I could perhaps mention it that we launched this call at the Farnborough Air Show this summer. I was there together with my colleagues Björn and Mats-Ola from the Swedish Defence Agency, and it was a great sort of launch. We had the director of ATI, and it was a nice exhibition, and we also had the Swedish ambassador to London, Mr. Solström, was there to give us some talks about the Swedish view and a little bit about also hearing about the importance of aerospace collaboration between our two countries. So perhaps we can hear some more about that and many more things. So please welcome Mr. Ambassador.
So good morning, everybody. My name is David Cairns. I'm the British ambassador here. So for plane geeks, the Vulcan is one of the most beautiful aircraft ever built. Yeah, maybe not so fuel efficient, but there's a fantastic book actually about written by called Roland White about how that was used to do the bombing in the Falklands War, and just how many Vulcans it took to get one to Port Stanley to do the bombing run and back. That's how fuel efficient. My first trip to Farnborough Air Show, I didn't see Vulcans, but I saw Harrier jump jets, and they were definitely noisy too. But it was great. And this is something about our heritage in aerospace. This year the UK celebrates the 100th anniversary of the RAF, and that's a really big deal for us. If I look back, you mentioned a little bit on our history. If I look back to UK, Sweden, aerospace and other cooperation, if you go back into the 30s and 40s, a little too much Junkers and Heinkel for my taste, but straight after that, de Havilland and others were here, and that's been great. Fast forward to today, and for example, our cooperation with Saab is fantastic. A third of every Gripen is pretty much supplied from the UK, and that's why we are big supporters of Saab exports, for example, to Brazil, where my Prime Minister helped land that deal. And that's really important. That type of collaboration is really important for us. And then also on the civilian side, one of my early visits in this country was to GKN up in Trollhättan, where again they're an important part of Swedish industrial life, and we're happy to support them. For me, the journey towards today and towards the launch in Farnborough back in July started again not long after I arrived, when Malcolm Scott of ATI came here, and we held a joint event at the residence around innovation in aerospace with ATI and GKN. These things take a while to sow seeds, but nearly 3 years later, it's really fantastic that we have this call for funding jointly with ATI and Vinnova. And I can't really stress enough how important this sector of industry is to the UK. Now, it's one of the absolute most important strategic sectors. And the UK and Sweden, we are both economies that are only going to thrive on high innovation, high R&D, high skills. And it's absolutely something that we are going to invest in for the future. And as you said, Carl, absolutely something that we want to do with partners and allies to make the most of it. So I, as Torbjörn was in July, really happy to do what we can to support this. Thank you all for coming today, and we really look forward to some interesting projects coming out of this. Thank you.
Thank you very much. And it's great to have you here and to have this introduction really to our future further discussions. And as you mentioned, and I also remember the breakfast meeting at the embassy was very nice. It was also get a nice insight in how important the collaboration is between Sweden and UK for this sector. We tend to forget that sometimes, that we use like a Swedish airplanes and Swedish engines, but there's a lot of collaborations behind all of these products, and also necessary to develop the future products. And we're happy to be part of this collaboration, Vinnova and Innovate UK, Innovair, ATI, etc. And even if the discussions were slow in the beginning, I would say that it's really taken off very quickly. I would say we had a meeting in January between us here in Stockholm. We decided, oh yeah, we use the Everca mechanism. It will be an easy way of doing it. And after that, it's moved very, very quickly. So we're actually standing here today, and the call is open. We're all ready to look at the proposals and your ideas for great innovation projects. And so then we will move forward in the program and listen a little bit about what is the type of projects we would like to see. And we will hear something from both Scott at ATI and Björn from Innovair. What is the strategy? What do we want to see from the industry side, from Innovair ATI? And then Justin and Lars will tell you a little about how do you actually do the application procedure when we have two countries. Will this be a massive bureaucracy, EU collaborations, etc.? I will tell you already will not be so complicated as you think. I hope so. Shall we move forward and let Scott and Björn take the floor and describe a little bit about what is it that we're looking for?
Good morning, everyone. So my name is Scott Pendry. I oversee the ATI's international program. And as you might expect, it's a role that involves a lot of collaboration, not only with international partners like Vinnova and Innovair, but also internally too in the UK. So it's great to be here with our delivery partner, Innovate UK, and Justin, my colleague, will be addressing you shortly. It's also great to have our embassy colleagues here as well, who have played such an important role in helping establish the call over the last 2.5 years. So before we go into the nitty-gritty and the details of how to apply, Björn and I will talk a little bit about the overarching rationale for the call. Why are we working together, basically? So first, a few comments on the ATI itself. So the ATI was established in 2013 to grow the UK's position in the civil aerospace industry. And as you know, it's an industry that is facing a lot of competitors, both advanced and developing countries, so China, Russia, Japan, all wanting a share of the market. And our role is to maintain the UK's preeminent position. It's a partnership between the business department in the UK as well as Innovate UK. And the money itself, it's a £3.9 billion programme that runs from 2013 to 2026. So when we break that down, it's £300 million per year, with £150 million coming from industry, and then 150 coming from the government. We have two principal aims. The first one is to set the UK's aerospace strategy. The second one is to manage a portfolio of investments, and we encourage people to come forward with ideas that are set against that strategy. So they've looked at the strategy and they can see what are the key goals for the UK. A central theme running through the ATI's work is, of course, international collaboration. R&D is becoming more and more expensive, and no one country alone can overcome the technological challenges that face aeroplane manufacture these days. And we've been, over the last 2.5 years, enormously impressed with what Sweden has to offer. We think the Sweden capability in aerospace is fantastic, and it's a natural, carefully considered collaboration such as this is a natural win-win for both countries. So a slide here on the development of the ATI. As I say, we were established in 2013. The top right there, that is the document I'd like to draw your attention to. That is the strategy. And that's available on the ATI website and indeed on the link to the call itself. So please do have a look at that. Another document I'd also like to draw your attention to is the project directory, which is again on the ATI website, and that might serve as a useful resource if you're looking for partners to collaborate with. It lists out all of the projects that we've done and is a really good indication of the type of projects that we would like to fund. In our strategy, we have 4 key themes. So if I just slowly take these in turn and just give you a flavour for what they're all about. The first one there on the top left, this is all about retaining the UK's ability to create a whole aircraft. So while we might not integrate the aircraft like they do in France and Germany, we do still retain that capability to produce a whole aircraft. And this is also about systems integration as well. Then we move over then, smart, connected and more electric aircraft. So this is all about connectivity in the aircraft, more intelligent and smarter communications, not only in the flight deck but also in the cabin as well, so improving the passenger experience. So we move down there, aerostructures of the future, a very important part of our portfolio. This is all about improving manufacturing processes to take into account complex geometries and advanced materials, and indeed just getting factories ready for the increase in aircraft production. Of course, you've heard Boeing, Airbus going from 50, 60, 70 per month, so that's a huge challenge for many factories. Finally then, propulsion of the future. Obviously propulsion, a huge area for the UK and Sweden too. This is all about delivering a step change in performance in propulsion as we shift from bypass to lower bypass ratios to ultra high bypass ratio engines, as well as increasingly looking at electrification. So that gives you a brief overview then of the ATI, and then over to Bjorn.
Thank you. My name is Björn Jonsson and I'm representing Innovair, the Swedish Strategic Innovation Program. I will fill in Scott's presentation with the 2 slides here about how Innovair has developed over the years. And we have been a strategic innovation program since 3 or 4 years now, but we have a history coming from the military side. And at 1919, it was decided to put some extra effort into civil development. I think it was during that time Sweden also produced the Saab 340 aircraft. But it's a strategic innovation area, and it's supported by government agencies like Vinnova, Defence Force, Defence Material Administration, industry, institutes and academia. And it's governed by a steering board who meets every year, but the work is carried out in a working group, and we meet regularly once a month and promote new ideas and take decisions on programs. We have now 5 running programs. The National Aeronautical Research Program, that's the one who was the base for Innovair, which started in 1990. We have a demonstration program going on, which finishes last year, and we have academia network, which we just have started, and also we support SMEs. We will hear some more about this later in the afternoon from Marie, with different projects. And last but not least, we have the internationalization part, where we have come very far with this call with United Kingdom. We hope that will also provide a lot of inputs for the next demonstration program, which we are starting to promoting now. And at the picture here, you see the strategic agendas we have developed over the year, and it's a little bit funny because in time it's about the same time that UK developed their agendas independently, and we have sort of in 2 different ways come to the same conclusion that collaboration could be a very useful tool. We have now started the work with a 2019 agenda. We try to develop it and publish it every 3rd year. And the objective is to promote good conditions for the industry, and we have put quite a lot of effort to get all the parts in the competence chain or development chain to understand their importance and their role. It starts with academia and stops with OEMs, who is producing aircrafts and engines. Okay. Yeah, and why are we doing this? Yeah, we try to provide services with high efficiency, like transport services for society, and high efficiency is becoming more and more important since it's very hard competition from new countries who wants to enter into aeronautics and aircraft production, create jobs and increase competitiveness. It's a growing business, and 5% per year we heard before, and that some prognosis say 30,000 new aircrafts within 20 years, and we want to be a part of that very large growing business. Meet societal challenges with globalization. People will travel more and more. And why do we focus on aeronautics? It gives good spin-offs to other sectors in society. We have an old dual use. It's quite well known, but there will be technology transfer to new branches too. So we have an expression, we call it multi-use today, and it's a good developed path to innovation here, because we have this, as I mentioned on the other slide, we have this start with academia and ends with OEMs, and everyone is aware of this industry-driven approach. And we're also setting trends for other sectors and trying to help or inspire other strategic innovation programs here in Sweden to follow us. Okay, that concludes my 2 parts, and I leave the microphone to Scott. There's 2 more slides.
So briefly then, we'll wrap up. So we'll wrap up then by just getting to the heart of why are we doing this? What is the underlying rationale? And quite simply, it's to accelerate the development of aerospace technology. So if we can work together, we can realize the market opportunity much quicker than conventional market forces would allow. And also, we've got a number of reasons there. So it's about gaining access to skills and infrastructure that's not available in our home nations. It's also simply about having a catalyzing effect. So we've alluded to the many conversations that we've had over the last 2.5, 3 years. But we think the call will act as that incentive to really enhance those relationships and develop some really great proposals. Finally, then, we also think this is a fantastic opportunity for the supply chain. So to become involved in one of our country's prime manufacturers will create opportunities not just now, but also in the future as well for future technology choices. Okay. Yeah.
I'm getting a bit unsure. Do you want?
Yep.
You sure you don't want?
No, it's fine.
You look good with this one on.
No, it's fine.
Okay, you don't want it, okay. But just before I leave the word to my colleagues in Innovate UK and Vinnova, now you listen to both the strategies of the UK, ATI, and Swedish Innovair. Is it still? Okay, now, okay. Okay, thank you. So before leaving the words to Innovate UK and Vinnova, please, do you have any questions regarding the strategies from ATI, Innovair? Any thoughts about, do you understand a little bit what we are looking for? Or are you waiting to hear more about the Eureka call mechanism? Because otherwise I suggest that we talk more about the call and the Eureka mechanism, and we will come back, of course, to more questions later on if necessary. And if you will find out, and I'm sure you will have some questions when you hear Lars and Justin's presentations about how you submit your applications. Thank you.
All right, thank you. Is it working? All right, thank you very much for the presentations. My name is Lars Nybom. I'm from Vinnova. I work here as a program manager, and I will be responsible for executing this call here at Vinnova. And together with me, I have...
So I'm Justin Davis-Trigg. I'm the Senior Programme Manager for Aerospace at Innovate UK. I look after the aerospace projects that are funded through the UK Aerospace R&D programme. So I will be looking after this call from a UK application perspective.
Thank you. So we have a mixed presentation. We'll see how it goes. First of all, I want to start off with explaining what Eureka is. Eureka is a intergovernmental network for international cooperation, and it was established in 1985. What it does is it provides frameworks or mechanisms to support market-oriented R&D projects, where the minimum criteria is at least between 2 countries. So to this date, we have 44 countries in the network, and the European Commission acts as one member. And the funding in these projects comes from the national funding bodies, for example, Vinnova or Innovate UK. Just to give you a brief look on the network, the green part is, they are the full members of the network. It is composed of 40 countries and the European Commission. But then we also have the associated countries, which is Canada, Chile, and South Africa. And we have a partner country that is South Korea, where you can collaborate together. And within Eureka, we have basically 4 major instruments. If we start from the bottom right, we have the Eurostars program, which is the an SME program within the Eurostars or the Eureka network. We have the clusters, which is industry-led R&D within different themes. Kind of similar to the Swedish strategic innovation programs, but on a Eureka level. Then we have the bilateral and multilateral calls through Eureka network projects, which we base this call on, that framework. And then we have Innovest, which is basically supporting SMEs or companies to find investment. So please.
Okay, so I'm going to talk briefly about the project requirements to start with. So this involves the UK and Sweden together. So we are looking for industrials on both sides when they're involved with the project. So one industrial in the UK, one in Sweden. It must be said here at this point for linked companies, so I will pick on one that's in the room, say for GKN. In examples like that, yes, both parts of the organisation, UK and Sweden, can be involved, but for the purposes of the application, you have to pick which country you're involved with. So you might put the side of the organisation that's taking the largest chunk of the funding might be the country you take, and you have to have another industrial on the other side. To lead, you have to be a business. It's industry focused. We're looking for really strong exploitation from these projects. The costings for a project we've put up there are indicative figures. We appreciate that currencies fluctuate, so at any point in time we can only just pick the figure we have at that point, so there are guidelines. When I come to the applications later, I will point out you need to be really careful on which forms you're filling out, what the currency is on them at the time. We do follow our national rules and regulations on funding as well, and projects should be within the duration of 12 to 36 months for funding in this call. We aim to be having the earliest start date the 1st of March, and we would look to have all projects started no later than the 1st July, both next year, those dates. The scope, we try to be quite broad with this as we've set it up. So the scope effectively is the respective national strategies. There are links on there, and hopefully we're going to share these slides after this meeting, so you'll be able to go on to any of those and follow it. So the UK participants, the technology they're working on should fit the UK strategy, and the Swedish participants should fit the Swedish strategy respectively. And as you've seen from Scott's presentation, in the UK we cover 4 areas, and then manufacturing processes and through life engineering services fit into those 4 categories as well, really. So it is a very broad competition in terms of the scope. There are some things that are out. We are looking for projects that are civilian primarily, although dual use would be acceptable. From UK perspective, we talk about aerospace, but for us that is in atmosphere. It's not outside the atmosphere. So a couple of clear distinctions we have to make there. So, eligibility criteria, I've sort of talked about some of these anyway, but so we've talked about the industrial partners, one on each side, and about linked companies. No individual partner or combined parties from a single country can take more than 75% of the eligible costs to demonstrate it is truly collaborative across the respective nations. That country of the cost, yes, yep. So, for example, in Sweden, your companies and organisations joining you could take 75% of the cost. In the UK, we would take 25%, but we wouldn't go over 75 to one nation, because we would consider that to not necessarily be collaborative at that point. Both in Sweden and the UK, we have funding rules where we do cap grant to 50% of the cost. That is not to say that organisations cannot go up to the maximum eligible under state aid rules within the EU, but then you would have a partner on each side who would have to take a knockdown on their grant rate to rebalance to the 50-50 funding ratio. Subcontract may not exceed 20% of any participant's total costs. Again, that's about grounding it in the UK and Sweden and making sure we have that good exploitation that we're looking for. You can have participants from other Eureka member states involved with this as well. However, they will not be funded through this competition. We will only fund UK and Swedish companies and organisations, respectively. They will have to have their funding set up, and we've got a line about that later coming up as well. And for UK applicants, you do need to sign the ATI framework agreement. Otherwise, we cannot share the information for the strategic assessment with ATI, and you will not be able to get through to be funded.
A quick look at the timeline for this call, and we will show another slide as well, but more detailed, that has more information about the UK participation, but this is more for the Swedish participations in this call. So the call opened right after the Farnborough event on the 23rd of July. Today we have the information meeting here at Vinnova. On the 2nd of November, the call will close. We will perform eligibility check on both sides. The UK will do it for the UK participation, and the Vinnova will do it for the Swedish participation. Then we will have independent assessment on in both countries, and on the 10th of December we will organize a consensus meeting between the 2 countries, between Vinnova and Innovate UK, to decide which project that we will bring forward for a so-called Eureka label. And the Eureka label basically says that you are eligible for funding in your respective country. but we will come back to that later on.
Okay, so a slightly less attractive side for the UK side. Unfortunately, this is the way we're forced down by our government websites. A few more dates in there because, as you will see later, for the UK strategic assessment, which sits alongside this, in both nations we are doing independent technical assessment and strategic assessment. For the strategic assessment, we have a few other things that we require on our side, and therefore we have a second application system that we have to, a file system we have to use as well. So there are a few extra dates on there. I won't go through those, but say we'll be sharing them afterwards. They are available on our website as well. So.
Let's go directly into the application process.
Okay. Am I pick up on this one?
Yes.
Okay. We are using the Eureka network programs. There is a core text out there that describes this call in a lot more detail than we're probably talking about today on the Eureka network site. And in the UK, we also have a guidance for applicants on our Innovate UK website. Got a brief picture of the call text there. Fairly generic. It should be fairly recognisable to anyone who's used Eureka before and bored it down. You can download it from the Eureka website. And if you need any help in building consortium at all, obviously there are many people here in the room today and on the WebEx watching by video, but there are contacts at Innovair and the ATI, should you wish to have help in that, in building up those partners. Just a quick image, if you go to the Eureka website, you can search if you put in UK Sweden, and it should take you to the next, if you click on this slide, so you should see this part, UK Sweden call for proposal in aerospace R&D projects, and you click on the green text there and it will take you through to the call where you get the call text, everything else.
Oops, sorry.
When you come to apply from that site, you'll see to this page, go to the bottom of it, which is the next click on. At the bottom page you'll see download the Eureka application form. That's the form you need to download and be completed by all participants of the project to be eligible for funding from both the UK and Sweden on this. And it provides us the framework from which we can do this call so quickly rather than having to set up separate bilateral arrangements which are taking a lot longer. So this is why we've selected this route. It provides the mechanism, it's well established, it enables us to do this quickly and relatively easily. Some people will find when they download it, they will get this error message come up. All I will say is speak to your IT department, you need a newer version of Adobe. Yep, on the Eureka site there's also guidance on how you should complete the form. A couple of key points here to recognise. When you go through, it is designed to also deal with two-stage competitions, so you will see costs for both stages. Please leave the definition phase blank. We are not having a definition phase here. It is just an implementation phase, so only fill out those boxes. It is in euros on this form, so you do need to convert your costs back to euros. That again is it's the rough figure at the time for currency, because when you apply to when you have the national bodies involved, we will fund you at the right value in the right currency. Duration is in per month, so you should fill that in as well. This is where I mentioned you can have Eureka members and associate countries can be involved from outside UK and Sweden, but they have to fund themselves. You can have participation from other countries outside of the Eureka network. However, that is slightly more difficult and you may wish to avoid it because it requires approval by the entire MPC network. So from UK side, we have Jane Watkins in the room. She's at the back there, who looks after Eurostars and currently Eureka for the UK.
We also have Peter Lindberg at the Swedish MPC.
Yep. So I'm sure they'll be available afterwards to talk to them about any other parts of Eureka, should you wish to. But they, along with others, the 44 others, remember the 44 in total, will have to approve that partner. So probably one best avoided. Also, when you submit your application, you do need to download it. You do need to have it signed by all applicants. And there will need to be a collaboration agreement formed and signed by all participants as well, but you don't need to do that until after the grant award. Submitting your Eureka application form, very simple. You can fill it online and save it online. We do recommend you give it a slightly different name each time you save it, in case there are problems. When it is completed, say you need to download it, it needs to be signed, put into a PDF format, emailed to projects@eurekanetwork.org, and in the email subject line, please put the words that are on the screen, UK Sweden Aerospace Call 2018. It is a manual process on the Secretariat side. They will have to go through the emails, so if it's not titled in a way that's easily visible, there is a possibility your application could get lost.
Okay, Swedish participation here. It starts with obviously visiting the Eureka Network homepage and download application form. The coordinator of the project, that is for the whole project, will then submit the application to the Eureka Secretariat. Vinnova will perform the eligibility check and a financial check of the participants on the Swedish side of the consortium. Then we have the assessment process, which I will describe later on. Notification of the success or not success in this call will be given on the 31st of January. And the Eureka labeled projects, the successful projects from this process, will be invited to Vinnova to apply for national funding.
So from a UK perspective, it's a very similar one, so I won't talk through this too much. We will come to the UK application in a bit more detail. We do have an extra step in there, via our FTP site. But again, we alongside, when the notifications go out on 31st of January, that's when we will have that. In the UK, we do provide our normal feedback to all applicants, so that will be available within 4 weeks of receiving the notification as per our standard terms and conditions. So, UK applicants. Unfortunately for the UK applicants, we do need some additional documentation for the strategic and value for money assessment. There is no way of getting around this to a certain extent, and I know, see the smile on certain faces of people from the UK. They know the process they have to go through. It is a bit lighter on this one. But you do have to register for our FTP site, which then gives you the additional forms and documentation to support completion in a public area, and you will be given a protected area, because we do recognise the documents we ask for may contain certain sensitive information. So you can register. You have to register online through the Innovate UK website. So you can go to our website, click on all funding opportunities. It will take you through to a page, which is next click. Here you can put in Eureka or Sweden equally, and it will bring you to a page. You click on the title agreement. It also has a link to the ATI framework agreement as well, which hopefully the first time this went out didn't work because the ATI changed the address it was on. So hopefully that's fixed now and is working. It opened on 23rd July and closes on the 2nd November, the same as the call. With Eureka, you can go to the end of the day to submit forms. In the UK, those who are familiar with the process will know that our sites always close at noon on the day. So if you are new to UK funding at all as a UK applicant, you need to be aware at noon we close the site. And after that, if the UK applicant hasn't submitted, we will consider the project ineligible. So you click on the link, go through, that's it. And it will take you through, and you'll be able to register. You'll be sent the links, etc., to be able to go through this. I'm not going to go through too much more. There is a next slide after this. There is a webinar we'll come to later that you can view. These are the additional documentations. We will require a copy of the Eureka application in PDF format, exactly the same. That's no different to what you send to the Eureka website, but we will need the additional documentation. So we will need the UK partner finance forms to do the checks, and if you do have as a second or third partner, so on, a academic partner, they will need to complete the JES forms and provide the PDFs as normal. the risk registers, exploitation plan, project plan are much lighter than we had before, and we suggest they are UK centric in what they're delivering, but you should put in there any joint tasks or deliverables from your Swedish colleagues who are involved in the call with you. Similarly, exploitation plan should be UK centric. So some will be aware of this. If not, we're happy to help people and sort of explain what's required. We can't tell you what to write, but we can help you with the process. I say there is a full guidance for applicants on the website that can be downloaded to look at, that gives more detail about how to complete this. And say hopefully we share these slides afterwards. A link to the recording. If you wish to listen to myself and Alexis Blades, our competitions exec, go through this in a lot of detail for an hour and a half. And we do go through the detail of every stage to guide you through it. Please go on to that, move through. And if you do need any support on the UK side, you're more than welcome to go to support@innovateuk.gov.uk. And it's a centralised service, but we always aim to give you feedback on your queries within 2 working days.
Okay, I will just quick one. I will just go through how this process of assessing the applications will look like. So on the top we have the consortium. The main participant will submit the application to the Eureka Secretariat by email, like we said before. Then the Eureka Secretariat will distribute these applications to Vinnova and Innovate UK. We will have our own national expert panel that will do the evaluation of the project proposals on both sides. And we have Innovair on the Swedish side and ATI on the British side, the UK side, that will do the strategic assessment if it fits or not. Then we will have a consensus meeting, like we said before, between Sweden and the UK, which will then give its recommendation to the Eureka network for labeling. After the labeling, you are eligible to apply for funding from Vinnova and Innovate UK, respectively.
So on the Innovate UK side, once you've completed and been through Eureka label, there is nothing further in terms of application to do with us. And I know the question has also been asked, the independent assessment will be done on the Eureka application form only. The extra documentation the UK is asking for is purely for the strategic assessment by ATI, and there's a line not shown on here which is value for money by our sponsoring department, which is the Department for Business, Energy and Industrial Strategy, BASE.
Yes, so for Vinnova there's an extra step after the labeling. That's when you have to register and do the application to Sweden. But that's basically just submit the Eureka project proposal, and then we will deal with it over here. Yep. Here's another slide with the same information. Worth noting is that we will use the Eureka methodology for assessing the applications. So we will use the same method on both the Swedish side and the UK expert panels. And the question you've been wondering, what is a Eureka label? It basically means that we bring the applications that has come out of this process to the Eureka high level group, and they will endorse these projects. That's the way it works. So, crystal clear.
There was a lot of information, and I'm sure we will find a way to put the slides on the web pages for those of you who couldn't follow all the details. But I also heard there is a 1.5 hour YouTube clip of Justin explaining everything, and I expect Lars and Peter will do the same recording in Swedish.
No.
One day. I'm very much looking forward to that. And I think we hope we have time for some questions here of a more general character that could also be interesting for the people watching on our web broadcast. Then we will have a 5 minutes or maybe 10 minutes break to get some fresh air inside, change the technology for the presentations from the companies after this, and we will continue. But are there any more questions so far? Greg has something.
Hi, Greg Wells from Rolls-Royce. Just one question in terms of the application process. So the application process is fine, that all seems fairly consistent. I guess once you're on contract, think I brought this up recently. What happens about monitoring within each member state?
Okay, so from a UK perspective, the UK participants will be monitored, required to produce all the normal monitoring documents, which hopefully some of the additional information you've given us will be form the basis of that. The project will be monitored on a quarterly basis by a monitoring officer, and then on a annual basis you will be required to complete a joint monitoring form, which is the Eureka standard one for the entire project, so that would be all participants together. We, between Innovate UK and Vinnova, will discuss the projects in the interim, so if there are any issues or risks we will be aware on both sides of those, but for the most part they will be monitored apart in that respect against by our own monitoring strategies. I'm not quite sure what it is on the Swedish side, so I'm sure
we will use Vinnova's standard monitoring practice, which is we have a progress report every 6 months, every half year, and then we have a couple of reports after the project is finished. And I assume that we have something within the Innovair also, since this is part of Innovair, the Strategic Innovation Program monitoring, but that's on a higher level. Yep.
And when you come to the end of the project, there are a couple of forms. They are the Eureka forms to fill out. So, Greg, you'll be happy to know you do not have to complete the Innovate UK closeout form at the end of the project. You have to complete the Eureka one. And then, I can't remember if it's 2 or 3 years after the project is closed, there is the market impact report that has to be completed as well.
Okay, so it's, but we will find ways of trying to synchronize, I expect, the reporting, and I suppose this is part for us civil servants. This is part of the innovation process for us. Try to synchronize monitoring projects in different countries like this. Try to make it as simple as possible, so we learn for the future. And also, please come back with feedback to us when the project is running. How can we do this better, so we know till the next time, hopefully. And now it's. I think it needs some oxygen in here. It feels a bit stuffy. So I would suggest we should be 5 or 10 minutes for changing technology and the presentations that we have after the break. Saab, Rolls-Royce, GKN, Corbon, could they perhaps make sure that the technology works during the break? And the rest of you, please take some fresh air, water, restrooms. So we take a break here and we'll be back 10 minutes from now, seated in 10 minutes from now. And the people watching on the web can also take a break and come back later. Thank you very much. Okay, thank you. Welcome back from your break. I hope you had some fresh air and water and are ready to listen to some more concrete ideas. Now we've had a lot about the details, and we will, as we said earlier, we find some way to put out the information from Lars and Justin on our web pages, so you can download the documents with the details and the links to the presentations and everything. Before our lunch break, we will have listen to some ideas for projects. First, we have 4 presentations from, and I need a piece of paper to see which order they come in. It's Saab, Rolls-Royce, GKN, and Corban Experience and SME. So, if everything's right, the first presentation will then be Göran from Saab. Talk a little about, no? Jenny from Saab. Can I? You need a microphone also. Do you want to have one of these, or do you have one? Okay. Anyway, very welcome.
Thank you. Do you remember this summer? Do you remember the football? It was very difficult being a Swede in the UK during the summer. I was basically daily asked which country would I kind of hope to win the World Cup, and especially before the England-Sweden game, I would say. And I kept saying that I think the best thing to do really would be to kind of have a joint team, and together we would actually win the World Cup. Unfortunately, that didn't happen. We didn't win the World Cup. Sorry about that. None of us. But now we have the opportunity to make a joint team, Sweden-UK collaboration, and I'm very happy about that. And I would say that Saab welcomes the opportunity now to work on this bilateral call. My name is Jenny Gardner. I worked as project director for the UK Innovation Centre in the UK for Saab. And I would specifically want to say thanks both to Innovair, Vinnova, also to Innovate UK and to ATI for hosting this kind of call, and to be so transparent and clear with the communication today. I think there were maybe not so many questions today, because basically there were not so many questions to ask. So it looks very, very clear indeed. I was asked to give some of the views from Saab on today's call, so that's what I'm going to do. First of all, I think we come from the standpoint that research and innovation is quite important for many reasons. One of the reasons is that the threats are increasing, and the complexity and technical development for the threats are getting more and more advanced and sophisticated. So for a defense company, it's important to be there and to meet and mitigate those threats. But also there are commercial opportunities. We heard earlier here about the idea of the kind of air traffic volumes and generally the development in aviation over the next coming years and how that looks like. But there are also opportunities, because we can see the infrastructure changing, the infrastructure with a different type of technology kind of that supports it now. We see it both on the vehicles themselves, the aircraft. We can also see it in infrastructure. And this is where we see a kind of a great potential. Saab works with research and innovation quite in a sophisticated way, and we've done that since the company was formed in 1937. So from that perspective, also the collaboration with between Sweden and the UK is quite fitting. Very quick nutshell. This is Saab. I checked kind of this morning. We're apparently number 32 of global defense companies in size, according to Wikipedia. But more kind of specifically, we have customers in more than 100 countries. We have about 32 billion Swedish crowns in turnover and about 16,500 employees. We work in all domains. So we work with aeronautics, and that's what I'm going to talk about today specifically. But we also work in on the water, under the water, and on land. So where it all began. Well, it was very much core. Saab's kind of birth, you could say, it was before the preparation during the Second World War. So it was 1937, and the idea was to build aircraft and to be able to build a Swedish strong defense. So you could say that research and development has been an absolute core of the company and is an absolute core of the company today. As I mentioned, the threats and the opportunities in the world are just there or even increasing. So this is really kind of what we're looking to do also for the future. We have done quite a lot of interesting things with aeronautics. We have had quite an interesting, you could say, journey with different spin-offs. Still, when I go around in the UK, most people say, "Oh, Saab, the car," which means that I have to explain that that was something that we actually did spin off from the aeronautics business, you could say, but it's not with us anymore because today we are a defense and security company. But it does underline the importance of research and development and also how we can spin off different technologies from what we do. And perhaps that's also something we can spin off from what we're going to do here together. I think it was said here both by our British and Swedish friends in the beginning how like-minded the two countries are and sharing many values. I also would like to highlight that there have been a couple of defense collaborations signed recently, and which again underlines the like-mindedness and the cooperative nature between the two countries, and where we feel also is a nice fit for our work. Saab has been in the UK for quite some years. I think this is kind of maybe so much not so well known, but we've been working in the UK. Our oldest business is really around training and simulations, where we already been kind of helping the British Army quite a lot, not only in the UK, but also all around the world. We have something called Saab CI, which works with underwater robotics in the south part of England, and we have a couple of other activities. For example, we have something called SAFE, which is control and command system that helps police districts monitor and action different activities in the districts. We have something called Digital Towers that plays nicely into what we're talking about today, which is about developing the tower where you do the air traffic management actually to a digital control room, which makes, gives it capabilities that a normal tower in no fashion has. So quite a lot of interesting things that we already are doing in the UK. Saab has also been very closely linked to the Royal Air Force, and we've been partnering on a couple of different things. I think the most recent news was from the 23rd of August now, when we come out and said that we also will help the Royal Air Force with a smart kind of self-defense system for their kind of aircraft. And this is just the latest, you could say, in a long row of collaborations of different types between Saab and the Royal Air Force. Saab is also, say my role now in the UK is also working very much closer with different institutions and academia and so forth to kind of build innovation in the UK, and for example very strongly with Sweden, also in other countries of course, but specifically with Sweden. And what we're doing right now is that we're looking at the stellar British academia, a long tradition of industrialization, and we try now to kind of look how we compare that with what we're doing in Sweden, which is again fabulous kind of technical and tech kind of knowledge, and also great investments in R&D in general. I think the latest thing I would just like to highlight that also plays really nicely into what we're talking about today is Saab went out now this summer and said that we are joining something called DARTEC, which is a Digital Aviation Research and Technology Center, together with Cranfield University and a couple of different partners, industry partners, looking at the future of flying. And that's very close to our heart, you could say, because it's both looking at the system integration, but not only in the aircraft itself, but also the system integration of the whole system of flying, you could say, everything from the runway, the airport, the sky, the aircrafts, etc. So we're quite excited about this collaboration. So looking at this particular call and research within specifically aeronautics, but also air traffic management, I just thought I'd mention a couple of really exciting kind of subjects that we are looking at specifically. One of them is integrated kind of vehicle health management, where you could say the new type of sensor technologies with the type of work that you actually can do with the data these days is making both, you could say, the health management itself, but also prognostics quite interesting, and you know how you could develop that for the future. Saab, we pride ourselves on being really good at system integration. So the model-based development of complex systems, it's something that we can see more kind of potential in. Multifunctional materials and composite technology. There's lots of really interesting developments now when it comes to materials. Some people talk about materials as the new internet. It's going to revolutionize things as we know it. We might not need to take it that far, but the truth is that there are lots of really interesting things that you can do with the new materials and the type of functionality you can get out of it. ATM systems, I already mentioned just a piece of that, but that's really around looking at the new future of flying, which will not again be only about the aircraft or the airport or the air traffic management. That will need to be more integrated. I think this is a particular kind of part also, not just air traffic management itself, but looking at, for example, the future of flying. You can see not only the aircrafts that we have today and drones, but we can also talk about future air mobility and what will that mean both for the vehicles themselves and for air traffic management, for example. Interesting potential. And then we have remote piloted aircraft systems and drones. So there we also see an interesting potential because I'm sure you've been following some of the discussions around autonomous systems, around electrical aircrafts and so forth. This was a couple of years ago seen quite with some type of hesitation, but I think this is now rapidly coming into the discussions about how can, for example, electricity, but also autonomous systems, how can they play into the future of flying. I would say that I have a favorite expression when I talk about innovation. So you could say that R&D is taking money, turning it into knowledge, and innovation is taking knowledge, turning it into business. So what I hope for this call and for the activities that we're doing here today is that we both will come with some really interesting new technology, but also that we can take it to other applications. I also hope that actually this will kind of maybe spin off. We talked about Saab the car, we talked about spin-offs here earlier. But also maybe that can encourage some of the STEM research and some of our younger kind of teenagers and so forth to be a bit excited about aeronautics, because personally I'm quite excited about aeronautics. So that was a bit it. Thank you.
Thank you, Jenny. Thank you very much. So I really hope we can see some innovations turn into business, and we as the Agency for Innovations can hope to provide some money as well into that. Thank you. And we shall move to the next company, Rolls-Royce and Greg. And please let us hear your thoughts and ideas about what you want to see more of in the future. Near future, far future. Try to be as visionaries. Jenny.
I'll try. Am I switched on? Yes. Hi, I'm Greg Wells. I work for Rolls-Royce. I'm head of our UK R&D programs. Okay, it's just as the slides are coming up. It's really great to be here today. We at Rolls-Royce, like Saab, are really interested in innovation. It's part of our DNA, as we say in Rolls-Royce. So really keen to be here today. We have been heavily supported by the UK government. We have a number of projects that were supported through Innovate UK and the Aerospace Technology Institute. So that's great. So it's great to do this bilateral opportunity today. So I'm going to just describe a little bit about who we are at Rolls-Royce. So, as some of you may be aware, apologies if I'm telling some people that all the things they already know. We're one of the world leaders in aero engines, and as you can see there, we've got an aero engine being tested in our facility in Derby. We're very proud of what we do. There's not many people that do what we do in the world, and so we're very, as I say, very proud of what we can deliver in power and propulsion systems, like many others have said today, both on land and sea and also in the air. Okay, we've just done, as some of you may know, we've just restructured our business. We're now split into 3 areas: civil aerospace, defence, and power systems. The bit I'm really going to focus in on today, really, as this is a civil application, is on civil aerospace, but I will just touch briefly on the other business areas that we focus on as well. So, what's our performance? We are just under £14 billion turnover. We invest significantly in R&D, 1.4 billion, and we, as you can see there, we've got a significant number of patents that we deliver each year. In civil aerospace, we're on around about 35 different aircraft types, significant numbers of engines that we support in service, and as some people have already said, we're actually seeing growth in this area by 2030 to probably having twice the numbers of aircraft in service than there is today. Significant numbers of employees that we support, just under 25,000 there. And then in the defence markets, we have over 150 customers, significant numbers in service engines, and also just under 10,000 employees. And our power system division as well equally has a significant footprint as well. Okay, so civil aerospace is our biggest business, just over half our turnover there, at just over £6 billion. It's huge, as you can see, this big engine being tested. This is our lifeblood of where I come from in Derby. It's a significant investment in the region, as well as other investments around the UK as well and globally. In defence, we also have significant investment, and also in power systems as well. So we have around about 50,000 employees globally. Around about just over a third of those employees are engineers. So we heavily support our engineering development within our company. We heavily support the education of engineers globally as well. We have a significant numbers of apprenticeships, 750 apprenticeship schemes. And we're really keen to sort of get out there into our various communities to support engineering and develop the engineers of the future as well. We have operations in around over 50 countries globally as well. This is our vision. It's what our strategy team came up with, it, pioneering the power that matters. So what we're really keen on is ensuring that the power that we develop from our aero engines is actually clean, it's safe, and it's also competitive as well, and meeting sort of legislative requirements. However, that's probably today. We're also looking quite heavily in the future, and I will touch on some of these areas at the moment. We're keen in terms of investing in the future, and you can see some of our electrification ideas. And if some of you were lucky enough to come to Farnborough, you may have seen us and also some of our partner companies on some of the stands at Farnborough looking at electric air taxis, looking at hybrid engines as well. We have a number of collaborations, as you probably may have seen if you were at Farnborough, of working with companies in this sort of new and novel area. But we see this as the future, so we've seen the car industry explode into this sort of all-electric opportunities, but we also see this opportunity in aerospace as well. In addition, we see that digitalisation is the future. We're investing quite heavily in this area, and then also we also see what are growing demands for trends for cleaner, safer and more competitive power. This slide pretty much says what I've already said. So I'll quickly move on. So this is just a portfolio of some of the engines we actually support in service. Some of these are in service on a number of, I guess, traditional in-service aircraft. The Trent 1000 is in service on the Boeing 787, the Dreamliner. And then moving along, these are some of our newer engines that are in service today. So the XWB is in service on the Airbus A350 and proving to be a very successful engine and very efficient engine. And then at the bottom here, you can see our evolution in terms of doing some large demonstrator tests, which I'll touch on shortly. The Advanced 3 was helped by both the UK government and also the European Union as well, in terms of helping us fund this programme to sort of advance our engine core, which needed some clear technology advancements. And then the Advanced 3 engine will actually feature in our largest ever fan engine, the Ultrafan, as some of you may be aware of, which we see as the next generational change in engine with its power gearbox. We have an approach to technology that we call our vision approach, where we look at technologies in the next 5 years and then the next 10 years. So the next 5 years would pretty be some of the technologies I just mentioned in terms of the Ultrafan. The next 10 years would be things in terms of the initial electrification market. In the next 20 years, even more radical ideas that you can see at the end in terms of that plane design at the end, the blended wing, as we call it. So these are some of the technology portfolio areas that we are supporting in terms of the architectural and design. We're looking at technologies that advance our core for emissions, which is key in the aerospace industry as we increase the number of aircraft in service and actually the fuel burn. We've got to look at better solutions that actually reduce fuel burn and particulates and NOx and CO2. So we've got projects working on lean burn. I've mentioned Ultrafan already. We're looking at how we do some of our digital design in the virtual engine, and we also have even some technologies around our engine core as well. We work quite closely with our catapults centres in terms of manufacture, in terms of advancing general manufacture as well. We're also involved in ALM, and also we're involved in specialist turbine manufacture as well to improve our capability in our hot core. To do some of this, we have a very large materials department, and we work with lots of academics and our catapult centres as well in terms of advancing the alloys that we require and new varieties of those alloys that we require in our engine design. We're also looking at composite matrix, ceramic composite matrix, CMCs, which will make us more competitive. They will be lighter, so therefore make us more competitive and also be able to withstand greater heat as well. And we're also looking at a lightweight composite fan system as well. When we look at our more intelligent systems, how can we operate more intelligently? So today our control system is pretty much based in a single control unit that's located on the engine fan. We are looking at potential distributed systems which give you greater accuracy, and also having those systems be able to cope in harsh environments on the engine as well. So those things are some of the portfolio that we're looking at within Rolls-Royce. Why do we need to do some of these things? This is just a very simplistic diagram. The Ultrafan engine is a good example of this. In terms of improving efficiency, we need to grow the size of our fan. As the fan grows, the engine core shrinks, and so this is what gives us our efficiency effect, and these are some of the demonstrator tests that we're working on today, but those require enabling technologies. So I mentioned some of the composite fan activities that we're doing, so we get a lighter fan, so it's more efficient and lighter weight, and so reduces the level of fuel burn. With a smaller core, it actually gets hotter. So our traditional materials that we use in the core, we're having to use other materials that I mentioned on the previous slide, and CMCs as well that I mentioned. This is just really reiterating what I've said, so I'm going to quickly skip on for the purposes of time. I've already talked about our evolution from 5 to 10 years. In terms of where we're located in a number of areas around the world in terms of also with our network of partner organisations. So this is why it's really key today, and I'm really pleased to see so many of you here today. We can't do all this on our own. We need partners. And so we're always keen to sort of look at who we can actually partner with. This is some of our growing network of manufacturing capability who we partner with in the UK that some of you may be familiar with. We have almost certainly a number of research projects going on with all these organisations throughout the UK, and also the UK government has been very good at sponsoring some of these organisations just directly, but also in association with some of the projects that we run within these organisations. And this has actually made us pretty successful in this arena. We were quite lucky to set up a concept that we call our UTCs, our University Technology Centres. We have around about 19 that are in the UK, but we also have global locations as well. These are great actually because some organisations have direct educational centres. We found that linking with key universities has been really beneficial to ourselves in terms of their specialist expertise. And we almost certainly partner with some of these organisations in a lot of our technology projects. And then this is some of our locations where we're based. I'm personally based in Derby in the UK, but we have a number of UK sites there that you can see, around about 16 sites in the UK, heavy footprint in the UK, so hence why we attract a considerable amount of government funding to support our projects, but also a heavy footprint in other locations around the world with various expertise. We're keen to support technology development. So during our life cycle of technology development, we not only do lab-based testing, we also do large engine sort of flight demonstrations. So we do a number of ground-based tests, we do flight test demonstrators, we run what's known as a flying test bed out in the US to actually test and execute some of our technologies on engine. And this is a really good way to prove that technology before it actually becomes a realistic commercial opportunity. In terms of where we think we're going in the future and what we need to do more of, and probably this is targeted at some of the audience in here, we need to be building our digital capability, which we are doing today, to support us in our service manufacturing sector design, and also how things link today, the so-called Internet of Things. This is just some data actually in terms of what it means in digital aerospace, so you can see the amount of data that is created when an engine is actually in service. We have over 1,000 aerospace customers. There's billions of data points that we actually measure and analyse through our engine health monitoring systems. We have to come up with smart algorithms to actually deduce what's happening in service, and then actually how that can improve our design and opportunity. So, and the ultimate goal here is actually by analysing some of this data, we get massive savings both from a performance of our engine, but also from our commercial activities with our customers as well. Most of you will have heard of Industry 4.0, so this is part of the digital and linkage into our manufacturing and supply chain. We also are key in terms of looking at high value design, and we have various departments both in the UK and Germany particularly, where we're looking at improving the way we design engines in a digital capacity. So there's lots of techniques and a number of projects that we're supported from various institutes at the moment. Skip over some of these and just moving on to some of the last slides. So this is our sort of evolution of propulsion. So today we have in service, I mentioned there's an XWB there, so the Trent XWB on the A350 is our current in-service engine. We are testing currently our advanced engine, and then we're moving into our ultrafan engine with its biggest ever diameter and power gearbox. We'll then be looking at a variable pitch ultrafan to even improve the efficiency of an ultrafan. And as we start going into the future, we've started engaging on hybrid electric engines as well to look at fuel efficiencies in terms of the acceleration and deceleration of aircraft during flight. And then as we get to a full electric opportunities, you can see the model at the end. So these are some of the things that we're looking at, and I mentioned that we're also interested in doing some full electric test flights for limited numbers of passengers at the moment. So we have a lot of technology that's going forward into the future. So through this call, what are we looking to? We really, as I mentioned, we really do wish to collaborate. We cannot do all this on our own, and our drive is to work with not just national but global organisations, both at, as I mentioned, our catapult centres, universities, SMEs, and other industrial organisations. And today we work with all those organisations. In terms of our linkage to Sweden, we're quite heavily partnered with GKN on our Ultrafan programme. But we also other collaborations that exist today, and I've given a couple of examples today there. We work with the Chalmers University of Chalmers Technology Centre, and we have done some work with them in fuel pumping. But we're also involved in when you actually get down to the smaller elements of our control system in harsh environment electronics with a company called Astracon as well. So we're keen to look for many opportunities that exist here in Sweden actually, and looking to look for collaborative opportunities that can help us on our technology journey. I think that's all I have.
Okay, thank you very much, and thanks for that, Greg. And thank you for coming here to Stockholm and tell us about your visions, and I really hope you will find some new opportunities through this call and more collaborations with Sweden. I'm sure there are lots of companies and researchers keen on working together with you and Rolls-Royce in developing this. And I think also electric aircraft is visionary, yes. Be interesting to see. That's really in the future. And the next presentation will be GKN, both Sweden and UK, and Robert will talk about that. See if we can find it. Okay, thank you.
Okay, so my name is Robert Lundberg from GKN here in Sweden. I'm normally working mainly with European research and technology programs, but I'm also involved in the Innovair Strategic Innovation Program. And I think I can claim that I was actually the one that came up with the idea for this bilateral UK collaboration between Sweden and UK. I'm not sure if it's right, but I think so. I'll write it in my memoir. So about 3 years ago, we arranged a trip to the UK, visiting key research centers, and well, 3 years later, we have a good program about to start. As you know, GKN is a British company, also big in Sweden. We have 3 main divisions: aerostructures and special technologies you find in the UK. And engine systems is what you find here in Sweden. So I'll talk about the engine system then first, or mainly all of my presentation today. So engine systems got the headquarters of the global engine systems division is in Trollhättan, Sweden. We are 12 different sites in exotic locations such as India and Norway, but the majority of the sites are in the US. About 2,400 employees in Sweden, and maybe some people remember that way back in history, like before 2012, we were called Volvo Aero, and then before that Volvo Flygmotor and other things from way back to the 1930s. We are active in the military area. We are, in fact, OEM responsible for the RM12 engine for the current Gripen aircraft. We also have a space propulsion division developing supersonic turbines driving the fuel pump for the Ariane rocket, and also the exhaust nozzle for the big main engine. But I'll talk mainly about the civil side today, the commercial engine side. And the nice picture you see there, it's not actually a GKN engine. We don't have our own civil engines, but it's not a marketing cartoon. It's actually a virtual engine printout. So we, thanks to our heritage and whole engine competence from the military side, we can actually do a full engine model and use that as a virtual engine to assess all the technologies we develop. So it's a good example of synergies between the military and civil side. We have a strategy or a component specialization or module specialization, if you want, on working on four distinct areas of the aero engine. Rotating parts in the fan, static parts in the fan, the low pressure compressor or booster, and static parts near the exit of the engine. We call this our 4-module strategy. It's been quite a successful strategy because we have been able to do business with all the engine OEMs. So today we are involved in more than 90% of all large commercial engines worldwide. Not only with Rolls-Royce, but with some of the competitors as well. But that means that we can be efficient for companies like Rolls-Royce, having a bigger volumes and so on. Looking at Rolls-Royce, then I've just taken some examples of engine programs where we are partners, like typically around the part called intermediate compressor case, which is a very complex structural part sitting in the middle of the engine. Interfaces with absolutely everyone, so we have to be very flexible, like Swedish people normally are, and talk to everyone. The component you see at the bottom there is a titanium laser welded and also using additive manufacturing, and those technologies were in fact developed by Vinnova funded programs and demonstrated in a demonstrator program, GF demo, and then turned into business on the Trent XWB for the A350 engine. I think things like this are printed with 3D printing on top of that. Not very big, but first flying application for us. As Greg said, we are also partnering in the UltraFan demonstrator in Clean Sky. So we are what's called a core partner in Clean Sky 2, which means that we are a strategic partner from day one to the end of the project. Also in Clean Sky, it's not only with Rolls-Royce, we are also on some other engines. And as a core partner, we can also launch our own calls for proposals to bring in new partners, which we have done with several UK partners, in fact, by chance, because it's a free competition. So, but they are good. So I wanted to mention a couple of other entities in the UK that we are working with or have been working with. I mean, it's just examples, not an exhaustive list, but so we work with the universities such as Loughborough and Oxford University, Nottingham, the Catapult Centres, AMRC in Sheffield, MTC in Coventry, the Welding Institute. I'm not sure if that's a catapult, but maybe no, but it's good anyway. Okay, so what do we want to do in the call? Well, we hope to be able to expand our collaboration with Rolls-Royce. We really like to work more with the Catapult Centres and also the really highly skilled universities. Some of them are centres of excellence for Rolls-Royce, I think, as well. But not only these, but we also have supply chain companies in the UK. Our supply chain, where we can get things like fiber fabrics for composites, castings, forgings, new alloys. So we are trying to set up some collaboration in that area as well, and looking also at SMEs. And on the Swedish side, then we want to involve I wrote Sfirea Research. Maybe you're called RISE Research Institutes now. I don't know, but at least we want to work with the research institutes in these projects, and also bring along some of our university partners like Chalmers, University West, KTH, Luleå. And you got my contact there if you want to send me proposals for projects. I should say something about the UK side as well. My colleague Adrian Bates, you got his email there as well, was unfortunately not able to join this meeting today. But I mean, I could say some words about I mean, the aerostructures in the UK and the special technologies. I think it's mainly around wing parts, around manufacturing technology for metals and composites. A very large center for additive manufacturing, which is also funded by the ATI, several projects. On the special technology side, there are things like smart coatings in facility in Luton, de-icing systems. So, but if you want to be in contact with them, send an email to me or Adrian Bates and see what we can come up with. Okay, thank you.
Thank you, Robert, and great that you could present both GKN UK and Sweden. And as we said, this is of course GKN is an important partner also in this call, and as Justin and Lars explained, it's you count as a company partner, and there's this little bit special rule: you can't have a project with just GKN UK and GKN Sweden. You need some other companies as well to get this true collaboration. But it's really exciting to see the way that you drive this collaboration forward. But there's not only big companies in this. We hear Saab, GKN quite a lot here in Sweden, and Rolls-Royce. But what we've seen is really important is also the small, medium-sized companies that are really crucial in this collaboration, that often brings forward the new ideas, and using the big companies kind of an engine to make them into reality. So one of these companies is Corbon, and we will hear some more about from Tobias. Will tell us what you actually do and what you're looking for in this call.
Thanks a lot. So I start again. So I'm Tobias Björnov from Corbon. We are an SME. We used to be very small. A year ago we were 7 people. And at the moment we're growing quite fast. This was from 2 months ago, and I realized I should actually have taken a new picture, because we're about twice as many now. So we're increasing with 3 to 4 new colleagues every week. And what we do at Corbon is we have developed a new process technology for producing CFRP parts based on induction heating. We heat from the inside. This way we can heat faster, produce faster, get a higher quality on the material. Yeah, and it led to a lot of new physical properties which enabled us to develop new applications. And yeah, we realized quite early that we needed some help to fully explore our technology. So our strategy is to license our technology and also to work with universities and research institutes. And we've been working, for instance, with Syria, RISE. We're also working with the AMRC in the UK. And we recently opened our Corbon Limited, actually. It's not a great office like Rolls-Royce or Saab, but yeah, so we employ 3 people in the UK to be able to take care of this collaboration. We have a couple of projects running, which I'll get into a little bit later. Yeah, so what's the big deal about this quality in our composite? We were able to reach a really high fiber volume, so we can reach between 70 and 86% in fiber volume. That means that we have less matrix in the composites and more fibers. So this brings out the best of the composites in physical properties, such as heat conductivity and electrical conductivity, etc. Yeah, I'm gonna try to be fast because I guess we're. Yeah, so our induction heating technology, we heat volumetrically in situ heating, so we heat the carbon fiber itself directly. We can also control the heating, so we can start from the center and go out, or from one side to the other, so we can control viscosity, different production processes. A lot of the production processes are dependent on heat for CFRP, so that's what we've been doing. Also, we discovered that there were no frequency inverters and production equipment for induction heating of semiconductors that were good enough for our purpose. So luckily some of my colleagues developed new frequency inverters and power electronics to suit the difficult to heat materials. So yeah, we typically reach 1/10 of the production time. So we have really fast throughputs. We save up to 95% of the energy, which is important for environmental reasons as well. I'm not going to talk too much. I have some videos here which will show. You see some different projects we've been running in qualification. The first one is a pressure vessel for hydrogen, type 4 for trucks. Then we have in-mold heating, induction welding and consolidation for thermoplastic and semi-crystalline CFRP. And we also do products, not only processing of CFRP, but we make induction heated rollers, plates, molds, etc. So this is an image of, or a video of filament winding with induction heating. We are using regular mandrels of steel, but we heat just the fiber and the surface of the metal to save energy. An example of induction heating welding, where we control the heat, and we are quite good at designing inductors. So we have a lot of patents in this area, etc. Pressure vessel with multiple materials and severe. Well, it's not very different layers and directions, so it's really difficult to heat. An example of in-mold, and this would represent RTM mold or compression molding, where we heat to 123 degrees Celsius, you can see on the side there. And then we cool it off again. So we can reach very fast production speeds. We're currently running projects of up to 8,000 RTM parts a month, and we're increasing that to twice that speed next year. Induction heated rollers can be used for different applications. In this case, it's for packaging industry. Being placed or close to Lund, it's not very strange. And this is what it typically looks like with induction heating in the center. This is a very good induction heating for metal. This is an example of what you would have on your stove at home if you have an induction heating stove. This is the heat pattern it generates. And this is what happens when you have a resistive heating. It takes the fastest path and then heats the edges typically. So if you compare that to what we achieve, where we can heat all the way out to the corners through the whole material at the same time, and also control the heating, you can imagine there's a lot of different processes that would benefit for this. And we're looking for partners to be able to explore these benefits, of course. Yeah, and these little boxes here, just to say that's the frequency inverters and the power electronics. And each, it's a modular system, like a rack system. So we place one of those, is 15 kilowatts. It goes up to about 2 megahertz in frequency. And there is microcontrollers and PLCs and all that. I'm not going to bore you with that part, but we stack them up, and then as many as you need. For larger objects are easier than small ones, actually. So aircraft wings would be an example, for instance. Yeah, so these properties has led to some products that we produce. We wanted to show that we could produce in larger quantities and qualify the technology. So the thermal conductivity, due to the high fiber volume, we produce heat exchangers, and we're currently scaling that up with a large heat exchanger manufacturer in southern Sweden. Electrical conductivity means that we can induction heat molds, rollers, plates for different industrial applications, which is also, we're looking for partners for all these areas, both in research and application and qualification of the technology. Self-lubricating, when you get the high fiber volume, gets low friction. So we developed a whole program of, you see down here in the corner a small image, but it's a ball joint that we developed for, to begin with it was for robotics, but now it's for car suspension, it might be for wing flaps, I don't know, we are not so involved in the aerospace sector so far. And then lighter and stiffer is also good, of course. We have more fibers, less matrix. And then this, with heating from the inside, as we can control the fiber volume and the injection flows and processes, we're able to make super thin laminates. So actually our largest product at the moment is radomes, high frequency radomes for the new 5G systems. So yeah, that's what we do. There are some images down below, radomes with 22 gigabit, it says, throughput, so you can push a lot of data through our radomes. And what can we heat then? If it contains an electrically conductive material, we can heat it pretty much, even really difficult materials. And even if it's really low in fiber volume, such as sheet molding compounds. Compression molding, RTM, autoclave. We want to use the autoclaves better, not always talk about out of autoclave technology, but maybe use the existing autoclaves in a more efficient fashion. Don't heat the whole autoclave, heat the part. Pultrusion, filament winding, so we've been running proof of concepts and qualification projects for about 6-7 years, and we have succeeded in quite a few areas. With lately much help from Swerea C-Comp and AMRC, etc. So, yeah, I already said that it's faster. We make lighter molds since we can heat uniformly. We can make light, thin molds. We don't need the big thermal mass to even out the temperature, since we can heat with a uniform heating pattern. Steel molds, carbon molds, all types of molds actually. So we tried a lot of different processing. An example of a product we make is heat exchangers, induction heated rollers. So this is, we produce the first, and then we have partners producing the inductors for the molds, etc. So we don't produce all of the power electronics and frequency inverters. We just developed it, and then we have partners subcontracted. I talked a bit about modular components, so we are making a lot of projects for robotics and suspension of cars, etc. Also, how to fix the parts together modularly, something that we developed and have some patents in. Altogether now we have 9 patents, and I think we have 5 or 6 more coming in these fields. Yeah, an example of the robots that we're building. We own 1/3 of the Swedish robot consortium. It's actually starting this month. So together with Prodtex and Cognibotics, is sprung out of the robotics lab in Lund, and Prodtex from Chalmers, I believe, from the beginning. And they do implementation of robotics in the UK, for instance, where we have robots at the AMRC, the factory of the future. We're also working on fixtures together with Prodtex. I believe it was the Locomax project to begin with, where we're making the fixtures lighter, stiffer. We're utilizing the ball joints and components that we developed for robotics. And we now found a nice application for it. And hopefully we will reach all the demands of the aircraft industry. So, yeah. Consortium building. We're too small, so we need to find partners always. Yeah, and talking about partners, we are partners with Sumitomo and Mitsubishi that are making the fibers, also in marketing and sales. They're promoting our technology, helping us in application projects. Scania recently invested in Corbon, which was thankful because we're going really fast. So we sort of have the hockey stick not in front of us, it's right in our face. So we needed some help. And then we have had lots of help from Evonik, ETC, EMS, which are making centrifuges for nuclear fuel, etc. And MEC, so to make the filament winding in our products. We have lots of academic collaboration with Lund University. Most of my colleagues are from there, so we're more expert than regular engineers, which we're trying to change at the moment, but we're getting there. KTH, Fraunhofer, Swerea, of course, with Marie and Bengt, I think he's here somewhere. Yep. And also Luleå University. And then we have a big network of companies where they're either customers or partners or both. So we're hoping to widen this for the aerospace industry. And hopefully we can set up a lot of collaboration with the UK. Currently we have one automotive project with a company named Williams Engineering in the UK. We're working with Prodtex, which has a subsidiary in the UK. TVI, I heard something about welding. So we're trying to implement our robots for that application. So, yep, that's it for me. So if you have any ideas, please contact me, or if we can help out in any way, we will. Thank you.
Thank you, Tobias. And I'm sure you had many people got ideas for how they can use your technology in many different fields, and I think it's also a good example how these ideas from universities and academia can grow into smaller companies, and those smaller companies can quite rapidly grow just if they find the right people to work with. Of course, yes. Thank you. Yes. Thank you, Tobias. No, and it's very nice for us also to see the examples of all the companies that we support in different early stages. Not all of them are quite as successful, but that's the risk we have to take, and that is really our role, to take risks also and step in with some kind of subsidies where it's actually needed. If we just put the money where there's no risk, then there was no big point to have us here. One of the institutes Tobias mentioned was Swerea, and Swerea is a very good example of the institutes we have here in Sweden that are really between the academia and industry, and it's very important then to help small companies meet academia. So Marie, please tell us more about Swerea.
Yes, I'm actually not going to talk at all about Swerea.
No, but you can just talk about how you work.
Yes. My name is Marie Jonsson. I'm the project manager or coordinator, I would like to call myself, for the SME efforts that Innovair has, supporting Swedish SMEs in becoming suppliers to the aerospace industry. So what Innovair wants us to do is to coordinate the SME program, which supplies companies, SMEs, with the possibility to run smaller projects to make themselves better at being suppliers. And also we host seminars and to increase SME competence. And a few years ago we had a project where we took Swedish SMEs over to the UK in order to create collaboration with UK partners. And we took 9 SMEs, Corbon was one of them, over to visit 2 catapult centers and network with British companies. And that was very successful, I would say. Some projects were started after this. And I know there's been a lot of discussions going on between Sweden and UK after this. And one of the things that we saw in this project was that there was a need for this bilateral funding, which we now can thank Robert for, for proposing. So we were very happy today from the SME side in Sweden, I think, about this. One of the things also that we saw in the project when we asked the SMEs why they wanted to collaborate with the UK was, of course, first on their agenda was to create new business. They wanted to expose themselves to new customers, to develop their market and build supplier networks. And often when it comes to these innovative technologies that the smaller companies have, they need to work together with a bigger company in order to gain trust and adapt their technologies and some such things. So I'm very happy to see that all the bigger companies presenting here have SMEs on their slides, because I want to say to you to, in this call, also bring them into your projects, because they often cannot supply the co-funding needed for these big projects. So you really need to rope them in a good way. Of course, also what they say is that they want to gain access to resources that are not available in Sweden. You have your catapult centers in the UK, which are very high density when it comes to competences and machinery and equipment. And we don't have the same sort of thing here, so it's a very good opportunity for Swedish SMEs to be able to work with them. And of course, they also want to increase their knowledge and exchange knowledge with companies and institutes and academia in the UK. And we heard that we are quite similar when it comes to how we work together, but there are some slight differences in business culture and how legal matters are handled, so they want to understand this more also. And that could be a good thing to do in projects in order to gain trust. But of course, there are, even though this bilateral funding hasn't been available before, these drivers has made Swedish companies already collaborating in the UK with UK partners. And one example is Creo Dynamics, who's going to pitch later on. Magnus Titus is here. Magnus, yes, over there. And they are a company that are experts in acoustics, aerodynamics, and smart structures, I would say. And they have already had a project with GK and Aerospace in the UK on highly rational NDT technologies that was a result from a EU project called Locomax. And in Locomax, they developed acousto-ultrasonic tomography technology. And they have later worked with GKN in order to industrialize this. And I think Magnus will explain a bit more what they want to do in the next step. So this is something that's already happening. Prodtex was mentioned before. And they are an engineering company that works with digitalization, automation, and tooling. And when they were Delphi, the previous name, they worked with Saab in developing technology for flexible fixturing. And Linköping University was also involved in this work, and this was commercialized by Prodtex. And they commercialized it in the form of what's called box joint technology. You can see it on the picture there. And in order to further develop this technology, they had to expand their market because the Swedish market weren't big enough. So they looked over to the UK and say, okay, there's customers that looks the same as the Swedish customers. You have Airbus, you have GKN. So what they did is they started working in projects there, and they now have a subsidiary there with 3 people hired. And they are actually part or members of the 2 catapults, AMRC and the MTC. So they have done this journey that Koribon was also doing now. A third example is Nexon Chemical. They are a Swedish company that develops solution for enhancing the property and performance of polymers. And they are situated outside of Lund, and they are currently actually working in projects on high temperature polymers with Rolls-Royce and also the National Composite Institute. So when we talk about having composite more and more involved in motors, Nexam Chemical is trying to do this and help this. They have a production site also in St. Andrews in the UK, I would say. So I will hold my presentation a bit brief. As I said, in 2016, when we went over there, we identified that there was a need for bilateral funding, easy access to this in order to help the SMEs building new projects and becoming this. So this is happening today, which is very good. And there are collaboration and development happening already together with the UK, but this will be further strengthened now, we think. So that was all from me. Thank you.
Thank you. And I think you can be very helpful in setting up and facilitating some of these collaborations. And you can also help a little bit later in the break to find connections and collaborations.
Absolutely, yes.
Yes. And to finalize, we also have some very, very short pitch presentations from smaller companies and other academics, workers who would like to present their ideas in about 3 minutes, and maybe some picture as well. And Lars, I think you know the order of them coming. So just call them up, and
we have written over there as well.
In this tiny, tiny little.
So the first one is Quintus.
Quintus.
Okay. Yeah, works. Good morning. My name is Sture Olsson, representing Quintus Technologies. And thank you very much for providing this opportunity. And as you said, it will be like a 3-minute pitch of our thoughts and so forth. But to start with, just a brief introduction of the company. Quintus Technology is a company based in Västerås, Sweden. And for most of you in the audience here, understand that it's a company coming out of the ABB organization. It has been in the market for 50, 60 years, providing commercial equipment into the aerospace industry primarily. Within the company, we have 2, I would say, business segments, both aiming at containing high pressure. Doing 2 things. One, either densification of metal. So it could be in industry of aerospace, it's typically castings. So we call it hot isostatic processing, or HIP. So hipping of castings is done in our equipment. And when I say Quintus Technologies, say ABB, we've been part of the ABB organization until late 90s. And since the late 90s, we've had financial owners been on our own for nearly 20 years. It's been a fantastic ride. The company has grown. But we also have different brand names. And it has been Quintus for 1.5 years. It has been Avior Technology. It has been Flow International, ABB, ASEA before that. So if you're familiar with hipping, you could also be familiar with the different brands that I just mentioned. The other side of the coin is metal forming. And we provide equipment for, again, containing high pressure to form sheet metal. And if I look at our customer base here in Sweden, Saab, GKN, yes. If I look in the UK, Rolls-Royce, yes. Also companies like GKN in the UK, yes. British Aerospace, Bombardier, all the major aerospace companies are customers of ours. And we then are an equipment provider. Being an equipment provider, we take pride in understanding not only how to engineer and manufacture the equipment, but we also take pride in understanding the customer process. Meaning that we have people in our application center in Sweden following very carefully what is happening with the material that you actually want to form or the material you want to densify. In the hipping area today, everybody talks about additive manufacturing. Additive manufacturing works very well together with a hot isostatic process as a second step to densify the material further. So that's an area where we see a lot of research going on right now. I will speak more in the next 2 slides of another process where we link the high pressure forming with metal forming. We heard today more composites coming in the aerospace industry. You have a need to cut weight in your design. For that purpose, we see, I would say, a threat to sheet metal in the aircraft to some extent, but we also see some opportunities. For that purpose, we have, again, with the help of Vinnova, worked on the project to go from traditional cold forming, where our equipment has been used for decades, to what we call warm forming, and with aim to form particularly titanium 6-4. And we've done a pre-study. We have installed a lab scale system in our workshop or in our lab here in Sweden. And we're now taking the next step into going in production. Our export from Sweden is, I would say, 98% of what we do is exported. The UK is a very important market to us. For that purpose, we do a lot of collaboration already. And as you can see on this slide, we collaborate with, for example, the FRC in the UK, in Glasgow. They've done some initial tests, very, very interesting if you want to dive down into the details. But what we're looking for now is a next step, the next phase. And what we would like to see is a collaboration between institutes, yes, to gain more data, more understanding of the whys and the hows. But we also want to see a collaboration with end users. We are an equipment provider. We supply to I would say, workhorses for the fabrication of aircrafts and engines, but not always directed to the OEM. Today, as you all know, you tend to have a longer supply chain. But the OEMs are important when it comes to spec setting. So we need to have a reach out, we need to reach people, we need to reach many levels in this process when you introduce new technology. And that's also important in the project. So hopefully with this short, I don't know, 3 minutes. If it also it's very short.
But it's very good.
Hopefully I plant some seeds, hopefully we'll get some connections, and hopefully we can push this forward.
Yeah. Thank you very much, Sture. And quickly move on to the next speaker.
Okay.
You, Svetlana, will say something about Linköping.
I'm not going to talk about Linköping, actually.
You can talk about...
Because I am going to present some project ideas.
Oh.
I was asked, actually, to present some project ideas, and I have a long list of project ideas. And hopefully Vinnova will be able to share this list with you. But I will also present a main project ideas that I myself and some other people plan to send proposal to this Eureka call together with Rolls-Royce. My name is Svetlana Stekovic. I'm from Linköping University, and maybe you wonder why Rolls-Royce, why not a Swedish company? When I finished my PhD at Linköping University, I moved to Derby and I worked 5 years at Rolls-Royce, and I had to deal a lot with Innovate UK and ATI strategic partnership too. But I don't remember you, it was somebody else, Mats. Yeah, but I think he's retired now. So it's okay. So regarding Eureka call, we are interested in materials, but also manufacturing processes, especially additive manufacturing. As a coordinator, I have 2 projects with Clean Sky 2. One is focused on mechanical properties of some novel Rolls-Royce nickel-based superalloys, and the other one is together with Saab, focused on additive manufacturing and titanium alloys. Okay. So the main project ideas is actually to try to understand what's going on during thermomechanical fatigue crack initiation in some novel alloys, nickel-based superalloys developed by Rolls-Royce. Okay. We have something similar, but it's called TMF crack propagation from Clean Sky 2. The lead partner is going to be Rolls-Royce, and then other partners is Swansea University, and they have very great mechanical test lab who can do testing, these mechanical fatigue testing for us, and then Linköping University where we will do characterization and analysis, but also modeling of TMF. And then we have a little company, SME from UK, Durley Controls, because they're developing some control or some software to control temperature in TMF rigs. But you see, Swedish company is missing. So we have to talk about that. Yes, I know. You got my list. You got it, but we need to discuss it. Okay, and then the other project ideas. If you find something interesting, you are very welcome to contact me or Robert maybe. So, or Rolls-Royce. So we would like to look at effects of defects on various mechanical properties at high temperatures for turbine disk applications, but also for turbine blade applications. We would like to look at some manufacturing and effect of defects after manufacturing of those mechanical properties. We would like to do some modeling and prediction work of these properties, and we do it with Rolls-Royce now. We would like to look at different phase angle effects during TMF or crack initiation and grow, but effect of different heat treatments on some phases and precipitates in turbine disc materials. I think you're looking a little bit, I think I have to speed up because it's too much technical details for you now. But okay, so we would like to look at coating CMSX4, at Telma gradients and the effect on fatigue life, at modeling of TMF, or both crack initiation and propagation. But let me go to additive manufacturing. The second project, we focus on design, on topological optimization and design tools, and we would like to continue with that. But also we would like to look at effect of manufacturing in these AM materials, especially effect of as-built surface texture on fatigue performance, and the damage tolerance of these defects, and also prediction. Okay, and this is the last slide. So yes, was it 3 minutes?
Oh, 4 minutes, but it's
okay.
perfect.
I'm late.
Thank you anyway. Thank you, Svetlana, for that. It's almost
no,
like
it's Sverige actually. Sorry.
Okay. Thank you anyway, Svetlana, for this smorgasbord of product ideas, and I hope you will find somebody. I'm sure you will find some people who like to taste more of those what you presented. So let's quickly move on to the next one. Sverige? Yeah.
It will be short, I promise.
3 minutes is a long time.
So my name is Mats Werke, and I'm working at the Department for Component Manufacturing at Sverige IVF in Gothenburg. And we have an idea with a project concerning minimization of machining distortions. It's a very common problem at many companies, and also in the aerospace industry, both GKN and Saab. One problem is when you remove material during machining, residual stresses would release from the component and cause the component to deform out of tolerance if you have bad luck. And that goes both for high strength materials like nickel-based alloys and also aluminum parts, for instance. So the aim of the project is to develop an optimization strategy, because you have to take into consideration the complete manufacturing chain, including forging, heat treatment, and machining. And we have the strategy will be based on tests, measurements, and simulation. And the aim is to come up with strategy to adjust process parameters and also workpiece geometry. And for now, we have a discussion, an ongoing discussion with partners in Sweden, GKN in Trollhättan, also Saab, and Brogan Industry, who is a supplier to GKN. And in UK, our main contact point is Advanced Forming and Research Center in outside Glasgow, I think. So we have actually weekly contact with them, and we discuss every Tuesday. So next Tuesday will be the next one. And there is also an SME in the UK that are interested. They're Wild Analysis Limited. They are actually the supporter of this simulation software. It's called Deform. And maybe, so actually it's ARFC, so it's the main contact point for Swedish English companies, but I just promote the project here, but they're responsible to connect English companies here. But I think that maybe Rolls-Royce may also be interested in this area, and so. But okay, good. Thank you.
Thank you. And it was exactly 3 minutes, so it was perfect. And who's cryodynamics, Magnus?
Hello, everybody. Can you hear me? Very good. Cryodynamics, I'm going to try to be in 3 minutes.
Oh.
I got a mail with 5 minutes, so I
okay.
can maybe negotiate it.
4 minutes already.
Very brief. Magnus Titus is my name. I'm the president of Cryodynamics since about a year ago. Going to make a short description about the company and then go into the pitch about the technologies and innovations we would like to develop. First about cryodynamics. Cryodynamics, we have a heritage from Saab in Linköping. It used to be the acoustic department of Saab about 20 years ago. Since 10 years, we are called Cryodynamics. 22 very, very talented innovators and engineers. About 10 of them are PhDs. It's like herding cats, but that's another story. We have three main competencies. We work in 3 areas: acoustics and vibrations, smart materials, and fluid dynamics, or CFD. And we are consultants, mainly consultants, and work a little bit also with innovation and research. Excuse me, which is very, very uncommon for a consulting company. We actually develop own IP if we can, and we develop it up until a demonstrator level. So then we need a partner, industrial partner, to work together with, and this is a little bit what we're coming back to. Just some examples of what we have done. We are working with active noise control systems in cars, a lot with the Chinese car industry at the moment. We work with turbines with, for example, Siemens. We have actually done some work with Ferrari F1 team to help them to do aerodynamic measurements or simulations in a good way. And we work with smart structures or smart materials. One example is that in the cars of the future, there will not be any loudspeakers. It will be the panels in the cars that will be the speakers. So the driver's seat, for example, will become the subwoofer. And these are things that we work with. Looking at our partners and clients, we work globally. Some of you are on this sheet. We have worked quite a lot with GKN. We have worked, of course, obviously with Saab. Rolls-Royce is not there, I think, yet. I think we'll get there. About 40% of our business is with aerospace. About 40% is with automotive or the vehicle side. And about 15-20% is with other types of industry like turbines and so on and so forth. We have 2 pitches. One project is actually a continuation on a project we have had together with GKN. And that is what Marie talked about on the acousto-ultrasonic tomography. This is a very robust and easy to use method to look at defects in composites. And what we need to do now, the next step, is to make it into an industrial product. And there we need a partner. We are doing some work with GKN, but we would like to broaden that partnership also to see in other applications and so on and so forth. It's a very straightforward method, which I like a lot. Then we have the second pitch, and that is a metamaterial liner. This is an innovation that we have done by ourselves, actually. And it's about a liner material that is with microstructures that can be used as a noise trap. Basically, we can tune it also, so it can be a tunal noise trap. And combined with the heat-resistant liner project we had in the Clean Sky project called Hostel a couple of years ago, we think this can actually take everything to a new level when it comes to noise reduction in the aerospace industry. Really, really interesting. But there we need help. We need to develop a proof of concept. We need to develop a demonstrator. We need to print out this material in 3D printing and find an application how to do that. And here we need partners. Okay. I'll be here for the lunch, so thank you.
Thank you. And the next speaker, and that was actually 4 minutes exactly, so no problem whatsoever. Don't rush, don't rush.
Good afternoon, ladies and gentlemen. I always forget the exact quotation, but I think it was, so Winston Churchill was asked to give a speech, and he was told, he asked, how long should I talk? Well, doesn't matter. Then I'll spend 5 minutes preparing. With us, we have 3 minutes, so we spend a little bit more preparing, but I shall try to stick to my 3 minutes. My name is Dag Åsa, and I'm the operations manager of Spacemetric. And what we are trying to do is just get my glasses. I'm presenting a project outline for discussion from 3SDL and Spacemetric. And this means that I'm trying to present our current thoughts. We're happy for input and we're far from fixed in our thinking. 3SDL is a UK defence and cyber data system specialist with a great background in solutions for challenging bandwidth environments and air experimentation. Do I? I pushed myself. I'm sorry. And also air experimentation for in-cockpit support and utility of smaller aviation platforms. 10 years of ongoing airborne ISR delivery for the UK MOD, for example. They have a huge list of successful projects. Spacemetric's Keystone COT software is sensor eclectic, agnostic. I prefer eclectic to agnostic. I don't go about doubting things all the time. That's agnostic. Eclectic is better. All embracing on-board, on-ground photogrammetric precision, rapid image data management handling system for still and video imagery from satellite, aerial and UAS sensors. We've got more than 10 years operational systems with the Swedish Armed Forces. The Gripen Rekipod is part of the reason why Gripen is so very rapid with its intelligence cycle in spite of its having no air-to-ground data link. And we also deliver the capability to deal with video streams from the Swedish Armed Forces UAVs, notably in Afghanistan and Mali lately. We have 15 years experience and more of satellite solutions for the EU, Copernicus, European Space Agency and commercial satellites. So we believe that combining our capabilities will result in synergies with a strong market potential. And to the left you see the overall ideas being amalgamated towards the middle, resulting in improved capabilities. And you see quite a few of our buzzwords and thoughts, thought describing words that you have there. But to give a few examples, more concretely perhaps, perhaps some components would be Keystone on board that would enable a low bandwidth video stream to be sent to the ground, simultaneously enabling rapid ground access to selected onboard high resolution imagery, while Keystone's user-friendly controlled dashboard allows air-to-ground data interaction, also in very low bandwidth conditions, all facilitated by 3SDL's communications solutions, allowing for example, near real-time satellite data to be transmitted into the cockpit of small manned platforms to enable and enhance rapid retasking. This last picture shows how we understand our thoughts to fit into the greater scheme of things, because you have, both from the UK and from Sweden, you have given us some material to look at to show us what you are interested in. So that's where we started. Now, I'm happy to try to answer any question, because I perhaps might not have used up my 3 minutes. No. But if I have overspent my time, I will of course stay on here. And I do wish to stress that we're looking for partners to help us think, and we are open to both partners inside this project. And of course, if any of you bigger boys want to discuss other stuff with us, that's fantastic too. Or girls, rather, as it were, from Saab, you're especially interesting for many reasons. Right, thank you very much.
Thank you. And thank you. Thanks for sharing your project ideas. And as I said, there will be plenty of time also after this, when we have some light lunch out there, and we can use the area outs here and inside here for smaller discussions that we don't need to show on the web seminar. So please just go through, and we will next is Devix.
Thank you.
Thank you.
My name is Erik Olsson. I work at Devix Mechatronics. I'm heading our business and team for polymer composites. Previously working quite many years in GKN in Sweden, so I have a big network in the UK, which we're trying to use here for a pitch. We want to look at automated fiber preforming with zero scrap, and the base is aerospace, higher volumes, reduced cost, reduced weight, what can be done. So we already started to talk to our friends and establish a consortium. So we have Saab Aerostructures on the composite side. We have a specific fitting that could be developed with the component specification from Saab, together with Devex, Shape, and Seacomp. And Shape is a UK SME that has the technology and knowledge around automated basically fiber stitching or preforming. Devex would do development of methods for design, and Seacomp material characterization and material modeling. And the idea is that this preforming technology is not available in Sweden today, and we could open up a new line of business in Sweden for Shape. And for Devex and Seacomp, we can promote our knowledge in composites for the UK market. We are open to additional partners. I know there are some interesting possibilities in here, but the idea would be to take this technology for the specific aerospace part to a TRL 4 or 5 level within the project. That's how you do less than 3 minutes.
Talk about Newsotech and what Newsotech has been doing for the last 25 years. It is a boutique, small boutique company in the northern part of Dalarna. And as you see, the stuff they produce is more like gold cards. This is a gold card you can't wear out. Okay, so go to the pub and you can't wear it out. The thing with this is that it's a Swedish invention since the early 90s, and the invention is that we physically reaction growth of a ceramic on top of titanium. This means that I can bend ceramic. Okay? The benefits of this is that we actually have the methods to do this is that we can control the surface properties such that we can reduce the friction to almost nothing. We increase the hardness from titanium being about 300 hardness Vickers to about 3000. And the gradient in between, depending on how much flexibility you'd like in the component, we can stop short and therefore having titanium 2 nitride, which is about half, say 1500 hardness Vickers. Having been around, most of you have seen titanium nitride on drill bits and so on and so forth. These titanium nitride things has been added on with vapor deposition methodology. It means you have an adhesive issue. You don't have an adhesive issue here. So I can bend this one into an L shape and the stuff will still remain. It won't flake. That's the key thing with this one. Ultra low friction, hard surface, essentially extending life cycle of the components that utilize this property. And of course, once again, it will not peel off. We have some experience with this. For those of you who are interested in satellites, it's been used in satellites in this type of shape for transmission of communication. Cassini, the last one. The one before that was Rosetta. This is stuff we cannot really talk about or could not talk about. Audi won Le Mans a couple of times, a number of times actually. And we reduced the friction in the turbocharger, in the engine, and they had hydraulic suspension to outperform pretty much anyone in the race. In 1996, these pipelines coming down here, hydraulic pistons rods was installed in oil rigs in the North Sea. The piston rods work such that they keep the pipelines in the vertical, compensating for wave motion. The piston rods currently, or that is mostly used, is made from steel and hard carbon. They have a life cycle about 12 to 18 months. These were installed in 1996. Design life was 20 years, and we're still operating 2 years beyond design life. Okay? Was that 3 minutes?
Thank you very much. Thank you very much, Mats. It was interesting, and it's. I actually visited T-Surf in 1995. I visited T-Surf in Uppsala when I was a surface chemist, long time ago. So it was interesting to see that it's still going strong. I think that was the last pitch, and then we talked about the presentation and the pitch lists of ideas. If you want, and it's possible, Innovair, ATI can probably put the list out on their webpage for more people to look at them. If you don't want them to be spread, it's okay. But let Björn and Scott know if you want to, if it's okay for you that the presentations are on their webpage. Yeah, you have to send them in now, so yeah, okay. So you can remove some pictures if you don't want to show all of them. And is there any other final words? Just go home and write your applications.
First, we serve lunch.
Yes. You will have
and
lunch
it will
before
be served out here.
Yeah, light lunch. And thank you all again for coming here. And I hope you will have some nice, good, fruitful discussions also during the lunch and in the afternoon. And we're really looking forward to all your applications. Thank you very much.